Hey guys, right, so we're going to talk about the Lewis structures and how to draw them as well. I have three examples here. Our first example is CLO3 minus, our second example is SF6, and our third example we're going to go through is NO2 minus. So, first things first, I'm going to write number 1 to indicate step 1. I should actually probably write just in subnote there. Step 1, there we go. So, step 1, I'm just going to start off by writing our equation there, our compound, so ClO3 minus. So, let's look at chlorine to start off, and chlorine is in group 17. If chlorine is in group 17, that means that chlorine is going to have 7 electrons, valence electrons, in our outer shell. And then we're going to add oxygen's valence electrons, which happens to be in group 16, therefore it's going to be 6. And you can see here that we have 3 oxygens, so we're going to multiply that by 3. We can also see that at the top we have a minus symbol, so that means that it's going to be adding 1 electron, because electrons, of course, are negative. So if we have 2 minus, then this is going to be plus 2 here. This number, let's work this out. So we have 18 here, 18 plus 7 is 25, and we have plus 1, which is 26. This is the number of electrons. So if we have 26 electrons, that means we can move on to step 2. Step 2 is going to be drawing our ClO3 Lewis structure in basic format. So let's start off with the central atom. The central atom is the atom which is in the middle. The atom which is in the middle is going to be chlorine. But why? Why is chlorine in the middle? Well, we can see that chlorine is the least electronegative. And remember, you can find your electronegativities on your periodic table, which I will show you in a minute. So around the outside of chlorine we have oxygen. So we have oxygen here, and we have an oxygen here. Sorry, it's a little bit tight of space, that one, sorry, not much space there. And we're going to put an oxygen down here. As you know, these are all bonded. Oxygen is bonded to chlorine, oxygen is bonded to chlorine, and this oxygen is also bonded to chlorine. So, let's bond them. Each 2 dots between atoms indicates 1 bond. So here we have 1 bond. Here we have 1 bond. And here we have 1 bond as well. We have, oh sorry, that's my mistake there. That should just be 1 there. So we have 2 here, 2 here, and 2 here. So the total number is going to be 6 so far. Again, I didn't mean to put those 2 dots there. So let's have a look at the total number, which is 26. So 26 is the total number of electrons. So we have 6 so far. So let's start on the outside atoms. We'll come back to chlorine in 1 minute. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So far, we have 24. but the actual number is 26 in total. So we actually need to add 2 more, but we can't add them to these because these have 8 in the outer shell now. These are following the octet rule. So the only thing we can add it to is the chlorine. Now, the reason why the chlorine can actually, this one is okay, this one has 8, but sometimes there are some elements that have more than 8. This is okay if it's in the center, we can have more than 8. It does follow our orbital rules, so in the center, don't worry if you have sometimes even 10, as we'll see later with SF6. So now we have our basic Lewis structure. We can move on to step 3. Step 3 is going to be determining the bonding and how many bondings there are. And we're going to follow our formal charge method. Formal charge is equal to the valence electrons minus the non-bonded electrons minus the bonding electrons divided by 2. So this is a formula. The reason why it's divided by 2 is just a part of a formula, I'm afraid. Just have to remember this. So formal charge, let's start with our chlorine component. We have a valence electrons. Well, valence is up here, so this one says 7. 7 minus non-bonded, well, we have 2 non-bonded. And our bonded electrons, we have 6. And of course, 6 divided by 2, which is equal to 5 minus 3 is going to be equal to plus 2. And let's write plus just so we can make sure we have the correct value there. So now we're going to move on to the formal charge of oxygen, which is going to equal, again, 6 is our valence electron, 6 from up here. Remember, it's in group 16, so 6. And we're going to have our non-bonded, which is going to be 6, minus bonded, which is 2. So we have 1, 2 bonded, and that's going to be divided by 2, which is equal to minus 1. Now we can write our formal charges on here. So we have minus 1, and minus 1. And of course, our chlorine is going to be plus 2 here. So we can see so far that we have from our CLO3 minus that we have plus 2 for our chlorine, minus 1 for one of the oxygens, and we have 3 of the oxygens, so minus 1, if you like. This gives us a total charge of minus 1. This is okay, but I think we can actually make this into 0. So in this case, if we want to make this equal to 0, we're going to start bonding with double bonds. The first thing we're going to do is to follow step 4. Let's just write step 4. So step 4, we're going to move this lone pair here, and we're going to put this lone pair into a double bond. So this is going to create Cl, and we're going to have 1, 2, 3, 4, and we're going to have oxygen here and oxygen here as well. So we have 1, 2, same as before for these two. These are okay. The only thing that's changed is we've just moved one lone pair to here to create a double bond. And of course our lone pair on the chlorine as well. So now that we have this, we can work out our formal charge of chlorine again, which is going to be equal to, that's oxygen, 7 minus our our non-bonded electrons for chlorine, which is again 2. This time minus bonded, so 1, 2, 3, 4, 5, 6, 7, 8 divided by 2, which is going to equal 5 minus 4 is going to equal plus 1. And now we can work out our formal charge. I'm actually going to label these This one here I'm going to say is OA, and these ones here I'm going to say is OB, because these types are the same. This is OB, this is OB, OA, much more simpler if I just call it OA, because OB is going to have the same formal charge as this one here. OA will be 6, as we said here, minus non-bonded, 1, 2, 3, 4, minus bonded, 4, divided by 2, which is equal to 2 minus 2 equal to 0. So far, this is looking good. But we still have the formal charge of oxygen B, which is going to be equal to minus 1, and we still have 2 minus 1. So actually, we can maybe even move another one down to create step 5, which is our final shape. This is going to be oxygen, and we're going to have 2 double bonded oxygens to our chlorine. 1, 2, 3, 4, oxygen, and we have 1, 2, 3, 4, 1, 2, 3, 4, and we have an oxygen down here, and this one is single bonded. Remember, this is an OB, as I call it. And now we have our formal charge of chlorine, which is equal to 0. If you calculate it, I'm just being a little bit lazy here, because I don't want to do the same thing over and over again. And our formal charge of oxygen A is going to be equal to 0, and we only have one oxygen B type, which is going to be equal to minus 1. You can see that the overall charge is going to be minus 1, which is fantastic, because this is the finished Lewis structure. So to finish off the Lewis structure, add brackets and then add a minus there as well. Now, step 5, we can calculate the Lewis structure, but for step 6, we might be asked what is the VSEPR geometry. The valence, sorry, I spelled that wrong, valence shell electron pair repulsion geometry. Let's go through that. So first of all, we need to decide the steric number, and we need the lone pairs. I'm just going to do this quite small, but hopefully it's clear. So let's take a look at the steric number. Steric number here is going to be 1, 2, 3, and we also have one lone pair here. So this is going to be a steric number of 4, and we have one lone pair. So this is talking about lone pairs of the central atom. And VSEPR, this is just saying about the number of lone pairs and the atoms. So steric number of 4, lone pair of 1. Well, we can take a look at our geometry to see where that is. Okay, so to just conclude that steric number is 4, and this one is going to be triagonal, and we're going to call it pyramidal, so there's only one pyramid. So here, this one is going to be drawn with our chlorine at the center, and we're also going to draw this with, we can maybe draw an arrow here, and we can draw our radial atom, so, and we can also have that one here. So actually 2 of these should be bonded, so you can actually draw two lines if you wanted to, 2 lines here. And we have our lone pair actually here. So this one we can just draw dot dot, oxygen, oxygen, and oxygen. Okay, so these ones maybe this is okay if you have a double bond. Just draw 2 lines. This is fine. Okay, and this is it for CLO3 minus. For SF6, let's take a look. So SF6, we're going to do the exact same again. Sulfur is in group 6, and fluorine is going to be in group 7. and we have 6 lots of fluorine. So if we have 6 sulfurs and if we have 6 valence electrons on our sulfur and 7 on our fluorine, this is going to be step 1, by the way. We can say that the total value of this is 7 times 6 is going to be 42, and 6, well, it's going to be 48 electrons. This is going to be a big compound, but not to worry, we'll do this fairly efficiently. So again, sulfur in the middle, let's have F, 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 and one more. 1, 2, 3, 4, 5, 6 there. Okay, so again, start with our bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And around the outside, so outside inwards, we're going to go from 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So actually this works out very nicely. This is really good. So now, next step is to look at our formal charges. So formal charge is going to be of sulfur. Formal charge is going to be 6 minus our non-bonded, which is 0, minus our bonded, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is going to equal, divided by 2, of course, equals 0. And our formal charge of fluorine, well, we can take any one of these, they're all the same. So we have our valence shell, which is 7, 7 minus our non-bonded, which is 6, minus our bonded, which is 2, divided by 2, which also equals 0. So this is fine. This is fine. Step 4 is going to be drawing it. So again, we can take this and we can say our steric number. Well, steric number, how many is bonded? Let's take a look. We have 1, 2, 3, 4, 5, 6. Any lone pairs? No, there are no lone pairs here. So this one we can just say our steric number is 6. Lone pairs, as we said earlier, is equal to 0. If we have 6 as our number and we have our lone pairs as 0, then we can say that this structure is going to be octahedral. 1, 2, 3, 4, 5, and 6. So we start off with sulfur, and we'll write fluorine here, draw an arrow here. They're all single bonded. This one's F, let's just draw that there, and our arrow things, F and an F up here. And of course we can also label this, oh sorry, no, it's not, that's octahedral, isn't it? Octahedral, there we go. So this one is octahedral, and each of these has about 90 degrees between them. Okay, so if you are asked to put the degrees in, you can say 90 degrees here. Okay. Okay, so for NO2 minus, this is the last question we have of the Lewis structure. So 5 plus our oxygen, which is 6, and that's going to be times by 2 and plus 1 as well. Now we have 5 plus 6 times 2, which is going to be 12 plus 5, 17 plus 1 equals 18. And remember, nitrogen group 15, oxygen group 16, 6, and we have 2 of them, and we have 1 electron more, so plus 1 electron is 18 electrons. Okay, and next, this is our step 1, of course. Step 2 is to draw this. N and O, doesn't matter. Bond, and 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Next up, we're going to look at our formal charges. So formal charge of nitrogen is going to be equal to 5. Remember 5 from here, the valence electrons. 5 minus our non-bonded. Non-bonded is going to be 2 minus our bonded, 4 divided by 2, which is going to equal 3 minus 2 is going to be plus 1. And again, we can work out our formal charge of oxygen, which is going to be 6 minus non-bonded, 6 minus 2 divided by 2, which equals minus 1. Okay, so again, like we said before, we're just going to move this lone pair here to create a double bond, and hopefully that will create this to be 0. We need this to get to 0, and we need this to get to 0 as much as possible. Step number 4, let's redraw it. So oxygen, sorry, that O is a little bit looking a bit funny there, and we have double bond here and oxygen here. So now our formal charge of nitrogen is going to be equal to 5 minus non-bonded, 2 minus bonded, 1, 2, 3, 4, 5, 6, divided by 2, which is equal to 0 now. That's fine, that's perfect. And formal charge of oxygen, let's say oxygen A again, is going to be 6 minus non-bonded, which is 4, minus our bonded, which is going to be 4 divided by 2, equals 0. And the FCOB, remember, is the same as this one because it's not changed, so this one's equal to minus 1. Okay? So now we know that we have a double bond here. Step number 5, we're going to say, is our steric number and lone pairs. Let's take a look. So we have our steric number as 1, 2, and we have 1 lone pair there. So that's going to be 3. Lone pairs, we have 1 lone pair included in the steric number. And this one is going to be, well, steric number and lone pairs. If we have steric number of 3, then we can look at what we're going to have, and 1 lone pair is going to be bent. And we can say that we have nitrogen as our central atom, and we have oxygen here, and we have double bonded oxygen there, and we have X, and we have X, or you can do dot dot, it's up to you. Doesn't matter, as long as you represent them, that is fine. And our geometry bonding is equal to about 120. We can say 190 and 120 is fine. We'll say 120 for this example here. It's probably around about 119 degrees, but in this case, we have finished. Okay. There we go.